Hello students, in this video we are going to solve some more numerical examples on the impulse momentum principle. So let us read the statement. A jet plane has a mass of 250 mg, means 250 megagrams, mega means 10 raised to 6, and a horizontal velocity of 100 meters per second when t is equal to 0. If the engines provide a resultant horizontal thrust F is equal to 40 plus 0.5 t kilonewton, where t is in seconds, using impulse momentum principle, determine the time required for the plane to attain a velocity of 200 meters per second, neglecting a resistance during the motion. Here the plane is moving horizontally. Say when t is equal to 0, its velocity is 100 meters per second. You have to find out the time t when its velocity is 200 meters per second. So what are the forces acting on the plane? One is the thrust exerted by the engines of the plane, which is given as F is equal to 40 plus 0.5 t. Second is gravitational force, which is acting vertically downwards. And the third is the resisting force that we are neglecting. So only two forces are acting. But plane is moving horizontally. So the gravitational force will not play any role in horizontal direction. Right? So we have to use the impulse momentum principle in horizontal direction. So first, you tell me what is Newton's second law of motion? That is rate of change of momentum is equal to force. Right? So that is m into dv by dt is equal to F. So m into dv is equal to F into dt. So integrating, when t is equal to 0, the velocity is 100 meters per second. When the velocity is 200 meters per second, you have to find out the time. Right? So this is change in momentum is equal to force into time, that is impulse. So it is impulse momentum principle. It is derived from Newton's second law of motion only. It is the application of Newton's second law. Right? So integrating m, we have v between the limits 100 to 200 is equal to, so F is given 40 plus 0.5 t dt between the limits over here 0 to t. So this is equal to, now integrating 40 t plus 0.5 t square by 2 between the limits 0 to t. Right? So multiplying with 10 raised to 3. Why? Force is given in kilonewton. So I am multiplying with 10 raised to 3 to make it newtons. So now putting all the values, m is mass of the plane. So mass of the plane is given 250 megagrams, that is 250 into 10 raised to 6 grams. So 250 into 10 raised to 3 kilograms. Okay. So now m, that is 250 into 10 raised to 3 into, yes, putting the upper limit 200 minus lower limit 100 is equal to, so it is putting the upper limit 40 t plus 0.5 t square minus 0 into 10 raised to 3. So you can cancel 10 raised to 3. Now you will have an equation, quadratic equation in t, that will be 0.25 t square plus 40 t minus 25,000 is equal to 0. So solving this quadratic equation, you get T is equal to 246.2 seconds. So that is the time required for the plane to attain a velocity of 200 meters per second from 100 meters per second. Understood? So we will solve one more example. So let us read the statement. A block weighing 200 Newton is pulled up a 30 degrees inclined plane by a force P producing a velocity of 5 meters per second in 5 seconds. If the coefficient of friction is 0.2, determine the magnitude of force P using impulse momentum principle. Here block is moving up the plane, inclined at 30 degrees, and this force P is acting along the plane. Now you have to find out the magnitude of this force P required to move the block from rest to a velocity of 5 meters per second in 5 seconds. Wherever the velocity and time are involved, then impulse momentum principle is best suited to solve that example. If the example is having acceleration or time, displacement, Newton's second law of motion. If the example is having velocity and displacement, work energy principle. If it is having velocity and time, impulse momentum principle. But anyhow, we have to find out this force P using impulse momentum principle. So to understand what are the forces acting on the block, let us draw first FBD. Freebody diagram of the block. So what are the forces acting on the block? Weight of the block vertically downwards, that is 200 newtons. Normal reaction offered by the plane, right, perpendicular to the plane, say NR. Applied force P along the plane, and friction force, the coefficient of friction is given 0.2. The block is moving up the plane, so the friction force will act down the plane. Coefficient of friction into normal reaction, right? So now taking x-axis along the plane, y-axis perpendicular to it, resolving this weight into two components, perpendicular components, parallel and perpendicular to the plane. This angle is given 30 degrees, so it is 200 cos 30, 200 sin 30. Right. Now the block is moving along x-axis. Now to find out the force required, you have to use impulse momentum principle in x direction. Here x direction means along the plane, right? So you have to find out the resultant force along the plane. So using impulse momentum principle along the x-axis. So what is impulse momentum principle? Change in momentum is equal to impulse, that is force into time. This force is the resultant force acting in the system. So here M is the mass of the block, weight is given 200, so it is 200 upon 9.81 into final velocity is 5 meters per second. Initially it is 0 is equal to, now what are the forces acting in x direction? One is the applied force, second the component of weight which is acting along the plane, right, 200 sin 30, third is friction force which is acting down the plane. So these three forces are acting. Now P is acting along the positive x-axis, so it is plus P. 200 sin 30 is acting towards the negative x-axis, so it is minus 200 sin 30. Again mu nr, that is frictional force, which is acting down the plane, so it is minus. Mu is coefficient of friction is 0.2 into normal reaction. Here what is the normal reaction? So in y direction, writing equilibrium equation, normal reaction is equal to 200 cos 30, right? So normal reaction is equal to 200 cos 30. So it is 0.2 into 200 cos 30. So it is the total resultant force in x direction multiplied by the time. Time is 5 seconds. So solving this equation, you get P is equal to magnitude of force 155.027 Newton. So it is the magnitude of force required to pull the block up the plane so that it can attain a velocity 5 meters per second in 5 seconds. Understood? Thank you.